Hello everybody, my name is Edivaldo. I work at Danfoss Climate Solutions. Welcome to this Danfoss ADAP-KOOL training video. And I am here today at Danfoss Mobile Training Unit to show you a very important topic of the AKPC 7H2A or AKPC 7H2B. And now, let's go to the laboratory to explore further this topic.
Today, the main topic is the heat recovery. And the agenda for this topic is here. Let's have a quick overview on the main purpose of the heat recovery and the types. After that, let's spend some words about the priorities of the system when dealing with the heat recovery and cooling together. And let's also check some sensors positioning. After that, let's go to the real controller to check some working concepts and real-time simulation. And let's go for it. In this slide, we have a transcritical booster CO2 system. The AKPC 7H2A controls the entire pack, and it also has the feature to recover energy which would be wasted to the ambient. In CO2 systems, the higher pressures and temperatures makes it possible to recover heat for tap water and heating. The remaining heat is removed using a gas cooler. There are two main types of heat recovery: hot tap water and heat recovery for heating. The regulation of the heat recovery in a transcritical CO2 system is performed during transcritical and subcritical stages. In the controller, we have the control of the gas pressure, so the system is able to reach the optimum COP even when the heat recovery is also taken into account. It's very important to say that the cooling system has always priority over the heat recovery to ensure maximum COP. The controller allows to use one or two heat circuits, depending on the needs. It can be hot tap water only, heat reclaim only, or both circuits. First, the circuit for hot tap water will take the energy it needs to use. The remaining energy is then available for use by the next circuit. If there is then any excess energy, this is removed with the gas cooler. In the circuit represented in this slide, we can see the hot tap water. And in the detail, it's possible to see the recommended sensors positioning. This regulation makes it possible to supply hot gas for heating a water tank. The regulation is performed for a tap water temperature of 55 degrees Celsius in this example. A temperature sensor STW8 is installed in the hot tap water receiver, and the temperature is controlled using a differential around the adjusted value. If either STW8 or STW4 are selected as the controller sensor, the reference can be displaced based on an external 0 to 10 volt signal coming from the customer. Now, some details about the V3TW valve. When tap water heating is required, the gas valve changes over and routes the gas in through the heat exchanger. The pump is controlled by on-off input, and it's cut in when STW8 is below the reference plus half the differential. It's recommended to use a pump with variable speed, so that the regulation flow does not have great fluctuations in the condensing pressure. A flow switch should be installed for safety reasons in case of pump failure. The controller will then disconnect the entire heat recovery circuit in case of flow fault. Let's have a look at the sensors positioning STW2, STW3, STW4, and STW8. All sensors must be installed due to safety reasons. For the STW2, it's important for the controller to know the temperature of the gas that is sent for condensation. The STW3 is used for temperature regulation. The STW4 is the heat exchanger outlet. It can be also used for temperature regulation. The STW8 is the receiver temperature. Let's see now another type of heat recovery. In this circuit below, which is very similar to the previous, we can see the heat recovery. In the detail, it's possible to see the recommended sensors positioning. The sensors have similar functions as the previous example, and the names changing according to the type of chosen heat recovery. This circuit is quite similar to the previous example, with the difference that now the excess of heat is used to heat the air and not the water. Let's take a look at the real AKPC7H2A in the laboratory, using the service tool to understand better how it works.
Now, I will use the tunneling feature to have access to the AKPC7H2A via the AKSM800A System Manager. This way, we can analyze the pack controller and check how it is working. In this application, we have a transcritical CO2 booster pack, configured with a heat recovery, the tap water circuit. Here in our laboratory, we can simulate the several conditions for a pack. Now, let's take a look at the heat circuits configuration and to our pack configuration. So I will first go to the configuration of the pack so we can have an overview of our system. So, configuration menu and select plant type. Our application is selected as a booster and high pressure valve. The refrigerant that we are using is the CO2 and the heat recovery is the tap water. Now, let's take a look at the heat circuits configuration. So here we can define the configuration of our heat circuits, in our case, the tap water. So the V3TW output type is set as digital output, the control mode is set as automatic, and the set point, as mentioned before, is set as 55 degrees Celsius. We will use the STW8 as a control signal for our heat recovery. We also enabled the variable speed pump and we will use a flow switch to monitor the flow. If we go down in the same menu, we can see the configurations of the pump. So we set as the minimum speed 30% and the maximum pump speed as 100%. Let's go to the status screen now. Here in the status screen, we can see that the compressors are running, the valves are opening, everything is running normal. But the heat recovery is set as idle now. It's not working. The V3TW is bypassing our gas cooler now. This is due to a digital input which is not enabling our heat recovery. But we will enable it soon. What I would like to tell you is that we have some conditions to enable the heat recovery. For example, the pump control must be set to automatic and you should not have flow fault. Another condition is that at least one medium temperature compressor must have been running for at least 2 minutes. And as you can see here, we have 100% of our capacity for the medium temperature pack. All the sensors should be okay, without any active alarms. There are other conditions for you to enable your heat recovery. You can find all these conditions in our user manual for the AKPC7H2A. Now, let's take a look at the status of the heat circuits. So here in this menu, you can see the status of the heat recovery. I will go deep into this menu. And here we can see that the TW status is set as idle. That's because there is a digital input which is coming from the customer, and this digital input is set as off. It means that the customer is not requesting the heat recovery to work now. The V3TW in this case is really bypassing the gas cooler because at this point we don't need it. And let's see below what we have here. The pump is not running and the flow switch is off, which indicates that there is no flow. Our set point is 55 degrees. We have our thermostat band of 5 degrees. And here we have our temperatures. I will simulate now the activation of the digital input, I mean the customer request for the heat recovery.
Let's see how it works now. So TW enable is off. I will enable it in 1 second. And after this, the pump should start. Yes, we have our pump. And also the flow switch should activate soon, because now we have flow. Good. Now we have our pump running, we have our flow switch, and the heat recovery. And the STW8 is very close to the reference. Our reference is 55 degrees. That's why the pump speed is at this point close to 100%, or at this moment it is actually at 100%. If we increase the temperature of the STW8, which I will do now, slowly, if we increase this temperature, you will realize that the pump speed will decrease. And the pump speed will always change according to the set point and STW8. Now we are above the reference, which indicates that the pump speed will decrease until the minimum, which we set as 30%. If the temperature of STW8 decreases again, which we will just simulate now, I will then decrease the temperature of STW8, and let's see what happens with the pump speed. Good, so you can see that STW8 is decreasing and the pump speed is increasing in this case. Good, and then it will reach 100% if that's the case, because we set the maximum for the pump as 100%. And as you can see, the V3TW is set as heat recovery, because now it's not bypassing the heat recovery anymore. The heat recovery is being used. And this is how the heat recovery works. Let's simulate now that our customer does not need the heat recovery anymore. So I will turn the digital input as off to simulate that our customer does not have any request anymore. So I will turn the TW enable as off, and you will realize that our pump is still running and the flow switch is still on. This happens because the pump will keep running for at least 108 seconds, and if there is no more request from our customer, then it will actually turn off. And if we go to the main screen, here you can see in TW status that it's shut down due to digital input, as I mentioned before. And now let's go to the main screen. Okay, now here in the main screen, we can see that it's shut down. It's exactly what we did via digital input, and you can see also here the temperatures. That's basically how the heat recovery works for the tap water.
And that's all for now. If you need further help, you're always welcome to reach your local Danfoss technical support. Thank you for watching this video. See you in the next video. Bye bye.